This is lesson 9. Slopes don't have to be positive. And this is activity 2. Stand clear of the closing doors, please. And what they're talking about is riding on a public transportation system. BART up in San Francisco or the trolley in San Diego. And you have to stand clear of the doors when you get on these systems. And so Noah buys a $40 fare card. He's going to ride on the public transportation several times throughout the next period of time. And he buys $40, puts $40 on the card, and every time he rides on the transportation system, it costs him $2.50. So it says down here how much money in dollars is available on his card after he takes 0 rides. Well, if he hasn't taken any rides yet, he's got $40 on the card. If he takes 1 ride, what do you have to do? You have to subtract $2.50 every time he rides on the trolley or the whatever it's called. It costs him $2.50. So 40 minus $2.50, $37.50. Takes 2 rides. That's going to be 2 times this $2.50. So now he has to subtract $5 from the original $40. So now he's down to $35. And then finally it says, well, what about an X number of rides, an unknown number of rides? Whatever number you put in there, you subtract that from $40. But first you have to multiply it by $2.50 because that's the cost for each ride. So let's say this is 10 rides. It's 10 times $2.50. 12 rides, 12 times $2.50. So you have to subtract $2.50 times the number of rides he took. Subtract that from 40, and that's going to tell you how much money remains on the card. Now, a problem that we're going to do in just a moment says how many rides does it take to get to $0? And notice, before we get there, notice that to get to $0, this number of rides times $2.50, what does that have to equal to make this whole thing 0? Well, it has to equal $40. So just this part right here has to equal $40. When it does, you have nothing left on the card. So if you used it all up, so how many rides gets you to make this part of the expression equal to 40? And that's a problem that we're going to do in just a moment. But first of all, let's look at a graph of this. So this is dollars on the card here. And notice that the dollars on the card are decreasing as you are increasing the number of rides. This is called a negative slope. Whenever you start drawing a line in the top left and you move to the lower right, that slant is a negative slope. And it makes sense. The amount on the card is decreasing. So it's a negative slope as the number of rides are increasing. All right, so how do you get that? How do you make that calculation and end up with a negative value? This is the whole thing completed. Actually, when I graphed this, I did every other ride because it was just easier to look at $5. So 2 times $2.50 is using up $5 each time. I could have graphed, and I do in the future, every ride. It just goes down $2.50. 1 ride down $2.50. 1 ride $2.50. 1 ride down $2.50. But because these are all labeled by 5s, I graphed it as 2 rides, and it decreases $5. 2 rides decreases $5. 2 rides decreases $5. All right, so let's zoom in. How do you get a negative slope? So the graph goes from $40, and just the number of dollars on the card goes from $40 and in 2 rides decreases to $35. So that the beginning point is 0, 40. 0 rides, $40. And then it ends, in this case, at 2 rides, $35. So this point right here is 2 rides, or 2 along the x-axis, and 35 along the y-axis. To get to this point, what I'd like you to do is start splitting this up into 2 parts. Look at first the horizontal part, so moving along the horizontal axis, that's the 2. So it's 0, you're going from 0 to 2 along the horizontal axis, and then look at it separately as moving along the y-axis. So it's a movement from here to here, and then from this point to this point. So this is kind of a transition. And so if you break it up mentally, or how you figure this out, into those two parts, it will become easier for you. So let's look at the change along the x-axis first. Well, where does it start? It starts at 0. That's 0 right there. Where does it end? It ends at 2. So it goes 2 units along the x-axis to get to this point right here. Well, you take where you end, 2, and subtract where you started, 0. Well, 2 minus 0 is 0. So that's pretty easy. So I'm going to write that down here. That's the 2 minus 0 is that 2 right there. Now, what about the change in y? What's this? What are these number of units along the y-axis? Well, where does it start? It starts right here, and that's the same as this 40 right here. So it starts at $40, and where does it end? It ends at 35. So it moves these $5 in a negative direction down to 35. So to do that calculation, take where you end, 35, and subtract where you start. So it's 35 minus 40. You have to get rid of where you start. And so 35 minus 40 is a negative 5. So this ends up being a negative 5/2 or a negative $2.50. And that's what happens. You subtract $2.50 for every ride that you take. So this is the same graph, and I filled in the points for every ride. So those are the alternate blue and red. So this is one ride, $2.50, two rides, $5, one ride, $2.50, two rides, $5, or one ride, $2.50. Anyway, filled it in. So finally it says, how many rides can Noah take before the card runs out of money? Where do you see this number of rides on the graph? Well, every ride costs $2.50. So how many $2.50 are there in $40? Well, to figure that out, you divide 40 by that $2.50 to figure out how many times you can take out $2.50. Every time you do that, that's equal to a ride. So 40 divided by $2.50, or 2.5, that's the same as 40 divided by 5/2. That's, to figure that out, what you're going to do is multiply. You're going to use the inverse operation. So we're going way back now. You're going to use the inverse operation, which is multiplication, and we're going to multiply by the multiplicative inverse, which is the reciprocal of 5/2, which is 2/5. And I always push to do this division first because I think it's easier, makes these numbers smaller to work with. 40 divided by 5 is 8, and 8 times 2 is 16 rides. It's going to be the answer. So how many rides before he runs out of money? The answer to that is 16 rides. Where does that show up on the graph? Way over here. Notice that this line crosses the x-axis. So the amount of money when it crosses the x-axis is y equals 0. So the amount of money on the card is 0 when this crosses the x-axis right here. So after 16 rides, you can place this point at 16. And what's the y value? The y value is 0 because you have $0 on the card. So that shows up right here. Now, so after 16 rides, there is $0 on the card. So the graph intercepts the x-axis. That's called the x-intercept at 16, 0. So 16 rides equals x, and $0 is equal to y. So this point is 16, 0. Now what I want to do is just take a moment and look at this more algebraically. We're going to write equations as we go further through this lesson. And so let's look at that expression that we wrote right in the beginning. So that expression is right here, 40 minus 2 and 50/100ths, or 2.5, times x. So let's look at that. And that's right here. So it says when the card runs out of money, that means when it has $0 on that card. So the number of dollars remaining on the card is 0. How do you get this to equal 0? Well, this part right here, and I mentioned this before, this part right here has to equal $40. So 2.5 times what number equals 40? So if you figure out what number to put in here for x and multiply that times 2.5, that's going to equal 40. And 40 minus 40 is going to equal 0. You have used up all the money on the card. So if this part of the expression has to equal 40, you can write that. 40 has to equal $2.50 times x, or 2.5 times x. So 40 is how many times 2.5? So this 40 is how many times this 2.5? Well, how do you figure that out? You divide 40 by 2.5. So now we're at the same point as over here, but this point we got here kind of by reasoning through it and making sense of the problem. Over here, we're using more of the algebra to figure this out. Now, we haven't gone into this algebra, we haven't studied that yet, but this is the direction we're going, and it's not that hard if you just put these numbers into the context of the problem. Well, 40 divided by $2.50, again, is equal to 16 rides. That calculation is right here, equals 16 rides. So this is more the algebra, and this is the more just reasoning through. How many rides? Well, I have to divide the total number on the card by the amount per ride. And that's going to tell me how many rides.